adjusted its chorus. But what began changing the mindset of the entire technical team was no longer the large and visible failures, but the nearly seeners. The young male engineer looked at the aircraft wing under the dull reflected light and wondered whether humans were truly capable of inspecting.
The young African-American female engineer did not answer immediately and instead continued observing the small vibration data flowing continuously across the screen.
Run the Level 3 diagnostic on the starboard engine. We need to check the housing tolerances before the next phase. Insurance. The matte gray aircraft rested silently in the middle of the maintenance hangar like a gigantic sleeping body. Yet deep inside it,
that was exactly when the central question of the future aviation industry began appearing more clearly than ever before, about whether aircraft could inspect themselves.
Within the disciplined silence of the maintenance hangar, the journey to transform the aircraft into a system capable of monitoring itself had begun. For many decades, aircraft inspection had always depended mainly on engineer experience, scheduled maintenance procedures. The young male engineer often had to spend hours beneath the landing gear compartment, searching for microscopic crack signs. The young workers worked throughout the night with flashlights, lifting vehicles, and inspection equipment. Every time the aircraft landed, the entire technical team had to rely on standard inspection procedures to determine whether any component was degrading before the next flight. Those procedures had helped the aviation industry maintain an extremely high level of safety for many years, but at the same time,
the young female engineer often faced situations where engine data changed very slightly, but not enough for the current procedure.
The young workers still continued replacing components according to fixed maintenance schedules, even though many parts were actually still functioning well. The entire aviation industry therefore continued operating based on a principle of absolute caution, but that very principle also. Then a problem began emerging when the number of sensors, electronic systems, and new material structures inside modern aircraft. The young male engineer realized that every flight generated an enormous amount of data about vibration, temperature.
The young female engineer began asking why, if the aircraft could already record every internal change within itself.
The young workers continued inspecting each area with handheld devices, but the speed of aviation technology development was making estimates.
The greatest contradiction began revealing itself when future aircraft were being designed far more intelligently, while the safety instantly heal. An aircraft could automatically adjust engine thrust according to weather conditions, automatically balance fuel systems, and automatically.
The young male engineer felt that contradiction becoming clearer each time he looked at the thousands of data lines collected by the system but still unable to transform.
As a wake account, the young female engineer began trying to analyze the very small fluctuations appearing before component degradation, and realized. The young workers gradually understood that the future of aviation would no longer involve waiting for failures to appear before repairs, but instead detecting risks long before.
And precisely at that moment, the most important question was clearly raised throughout the maintenance hangar about how an aviation. The answer began appearing through the combination of microscopic sensor networks, artificial intelligence data analysis, sensors placed throughout the wings, fuselage, engines, and hydraulic systems would record microscopic changes in vibration.
The artificial intelligence system did not simply read isolated data, but instead learned the entire normal operational condition of.
That meant when an engine began vibrating differently by only a very tiny percentage, the system would recognize the abnormality before engineers even saw physical signs.
The young workers inside the maintenance hangar gradually began changing their roles from directly searching for failures into confirming and handling.
Future aircraft therefore would no longer wait until scheduled maintenance periods to be inspected because they would continuously evaluate their own health conditions during every flight and under.
The young male engineer understood that this was the greatest transformation in aviation, from reactive maintenance toward predictive maintenance.
For gestures. The young female engineer continued explaining that the self-inspection system could also accurately determine degrading areas.
And that was exactly why future aircraft would possess the ability to monitor themselves, because enormous data volumes combined with artificial intelligence.
However, the most important matter was not that aircraft could detect failures themselves, but rather how they understood difference between normal conditions and truly.
The young male engineer realized that a modern aircraft did not operate identically every day, because weather, load conditions, and
that forced the self-inspection system to become intelligent enough to understand which changes were naturally normal and which signals indicated.
Future artificial intelligence would not simply rely on fixed limits, but would instead learn the unique behavioral patterns of each aircraft.
The young workers inside the maintenance hangar gradually saw the clear difference between the old method based on scheduled maintenance and the new system.
Within the old model, healthy components were replaced based on scheduled limits, but the new system accurately evaluates the true lifespan of every component. The young black male engineer understood that this would not only reduce costs, but also increase safety, because small degradation signs. The young female engineer also realized that future aircraft would no longer function like silent machines, but in formats. The young workers now no longer worked only with wrenches and physical inspection devices, but also had to understand data, predictive. That transformation showed that the future of aviation maintenance was not about eliminating humans, but instead turning humans into collaborators with aircraft capable of understanding their own conditions. The young male engineer stood beneath the matte gray narrow-body aircraft and realized that what the aviation industry pursued,
self-inspection capability, was not technological magic, but the result of listening to every smallest signal emitted by the aircraft.
The young workers inside the maintenance hangar continued working within that clean and disciplined environment, but their roles were gradually changing.
Future aircraft would no longer be machines reacting after failures occurred, but would instead.
That did not reduce the role of engineers, but instead made their responsibilities even greater, because they had to understand how to interpret the signals sent by self-monitoring systems every single day. The young male engineer finally understood that future aviation safety would not only depend on stronger materials or more advanced engines, but
the young female engineer also understood that the smartest aircraft was not the fastest aircraft, but the aircraft that always knew its own condition during every second of operation.
The young workers continued walking beneath the cold white lights inside the maintenance hangar, where matte gray aircraft were gradually learning how to listen to their own bodies.
And perhaps the entire future of aviation would ultimately be determined.
And perhaps the entire future of aviation would ultimately be determined not only by how humans built aircraft, but also by how aircraft learned.